So we have Joey, who has a weight of 441 newtons, sliding down the banister of the stairs in his house at a constant speed. That sounds like it might be important, so I'm going to underline it. The banister makes an angle of 38.0 degrees with the horizontal. What is the normal force between Joey and the banister? So we're going to draw our free body diagram. And you'll notice that my banister looks an awful lot like the plane that my trunk was resting on because I don't draw them any differently. So here's Joey. And he has an F of G that's equal to 441 newtons. And if we tilt our head, it's easier to do perpendicular. If we tilt our head, we can do our normal force. And we know that opposing the direction of motion is friction, and in this case specifically, it's kinetic friction because he's in motion. Now, based off of what we learned already, it's much easier to break our G, our gravity force, into X and Y. So when we do that, we get F of Gx and F of Gy, and I'm going to put my right angle in there. And we know that if this is 38 degrees, then this is 38 degrees as well. Now we can talk about what we know about this. Because he's at a constant speed, there is no acceleration. So that means he's at equilibrium. So the forces in the x direction are equal to 0, which means that F of Gx is equal to F of Fk, the kinetic friction force. And we also know that the sum of the forces in the y direction is also 0. And we know that F of Gy is equal to F of n. You can see we haven't even talked about what needs to be calculated because we know that we're going to do this far. In fact, we're going to go ahead and break our gravity force into X and Y because that's what we need always. But let's see what we're solving for. In this case, we're only asked to find the normal force, which we just said was F of Gy. So we don't actually need the F of Gx in this particular problem. We can just solve for the y, and then we'll have our normal force. So we can see our y is adjacent, which is k. So we will do cosine of 38 equals adjacent of our hypotenuse. So our adjacent is equal to 348 newtons, which is also equal to our normal force. So in this case, you didn't have to do anything with this, though we could have used it and we could have solved it and used it to tell us stuff about the friction. We could have solved for just the friction force, or we could have solved for the coefficient of friction because we also know our normal force. These are the kind of things I would typically ask you about in a problem like this.